In this video, I'm going to look at atoms. So the first thing we need to say is that atoms are the building blocks of everything. This whiteboard's made from atoms. The ink on the whiteboard pen made from atoms. The whiteboard pen's made from atoms. And we are made from atoms. The next thing we need to say is that if a substance is made from only one type of atom, it's called an element. There are just over 100 elements, and these can all be found on the periodic table. And the final piece of information in this opening section: atoms of elements are represented by symbols. For example, the symbol O, that's a capital O, represents atoms of oxygen, and the symbol Na, and that's capital N, lowercase a, represents the atoms of sodium. In the next section of the video, I'm going to look at what atoms are made from. So you can see on the board there, I've drawn up an empty table for the three particles that make up atoms. We need to know the names of these particles, their charge, and their location. In other words, whereabouts in the atom can they be found. So the first particle we'll look at is the proton. So protons have a charge of +1, and they are found in the centre of the atom, which is called the nucleus. Next we have the neutron. Neutrons have no charge, and they are also found in the centre of the atom, the nucleus. And the third and final particle is the electron. That has a -1 charge, and that is found in what we call energy levels, or you can call them shells, and they are located around the outside of the atom, so outside of the nucleus. So I'm sure you'll be familiar with diagrams like this, which sort of represents the atom, where we have the nucleus right in the middle. This is absolutely tiny, and inside the nucleus we have the protons and the neutrons, and then this here represents the first energy level or shell. So we've got electrons in there, and then once that's full, and I'll come on to the rules for filling up these electron shells later on, once that's full we have to occupy the next energy level, and once that's full we go to the next energy level, and so on. So what we're going to look at now is how do you work out how many protons, neutrons and electrons an atom of a particular element has. So we'll use sodium as our example, and you can see I've written on the board there the symbol for sodium, Na, and there are two numbers there. There's the smaller 11 and the larger 23. So the first thing we need to say is, what do these numbers represent? So the smaller number, so the 11 in this case, is what we call the proton number, or you can call it the atomic number. And essentially this number here determines what the atom is. So because sodium has a proton or atomic number of 11, what that's telling us is that atoms of sodium have 11 protons. Now you can see I've also just done a little reminder there of the charges of these particles. So protons are +1 charge, and we've got 11 of those. Now another thing we need to know about atoms is they are overall neutral, so they don't actually have an overall charge. So if sodium's got 11 protons, 11 pluses, it must also have 11 minuses. So this 11 here is telling us how many protons and how many electrons sodium has. You can see I've labelled up the other number there. The 23 in the case of sodium is what we call its mass number. And what we can do is we can find out very easily the number of neutrons by subtracting the proton number from the mass number. So atoms of sodium have got 12 neutrons. So what we'll do now is we're going to turn this information here that we've gathered from these two numbers into a diagram of a sodium atom. So you can see I've already put in the information about the nucleus, 11 protons, 12 neutrons, and I've got 3 available energy levels or shells that I'm going to put the electrons in. And hopefully by the end of this little section you'll understand the rules for filling the electron shells. So what you've got to remember about energy levels or shells is you must fill the lowest available one first. Once that's full, you move on to the next one. So the first energy level can hold 2 electrons. So the first 2 are going to go in there. That shell's full now, so we need to go into the second energy level. And the second energy level can hold 8. So you can see that's full now. So let's do a quick check. How many electrons have we got left? So we've used up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 11 in total. We've got 1 left. So that needs to go into this third energy level. You can see I've changed the electrons from capital E's to crosses. And that's because when we draw diagrams like this, we use crosses to represent the electrons. And you can also see that I've written up the electronic configuration, we call it, for sodium. So it's 2, 8, 1. That means 2 in the first shell, 8 electrons in the second shell, and 1 in the third shell. So one for you to try now. How many protons, neutrons and electrons does an atom of oxygen have? And then if you want to have a go at drawing a diagram to show the representation for an atom of oxygen, and then I'll go through the answer. So atoms of oxygen have 8 protons and 8 electrons to keep the overall charge of the atom neutral. The difference between these two numbers is also 8, and so oxygen atoms have 8 neutrons. So the drawing now, we've got the nucleus in the centre of the atom with 8 protons and 8 neutrons in, and the 8 electrons, 2 would live in the first shell or energy level, and then we need to fill the next one, or start filling the next one up. 1, 2, 3, 4, 5, 6. So the electronic configuration of oxygen is 2, 6. For the GCSE, you need to make sure that you can do exactly the same for the first 20 atoms. So that's hydrogen with a proton number of 1, so that's atom number 1, to calcium, and that's atom number 20.